Hello everyone, I am Dr. P. Kumari, working as Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. Today in this video, we are going to learn about solution of non-homogeneous linear differential equations, method 3. So in the previous videos, we completed method 1 and method 2. So what is the method 1 is in place of q of x, we are having e power ax. That is the method 2. Coming to method 1. So that is q of x equal to sin ax or cos ax. So if you are having these two values, we are going to solve the problem by using the method 1 and method 2. So today we are going to discuss about method 3. So that means in that method 3, what is the value we are having here? First, we will discuss about what is the solution of the linear differential equation. So, linear differential equation solution with the constant quotients is, first of all, what is the equation form? Equation form is f of d into y equal to q of x, or f of x we can write. So, here for the f of d, first we will calculate the complementary function. So, here complementary function is the one solution, and we are going to calculate particular integral by using the q of x. So, this is the one solution. So, for the homogeneous equation, so we are having homogeneous equation in the form f of d into y equal to 0. For this homogeneous equation, only complementary function is the complete solution or general solution. So, but here for the non-homogeneous, that is f of d into y equal to q of x, for this the solution is y equal to CF plus PI. So, what is the meaning of CF is complementary function, and what is the meaning of PI is particular integral. Here we have to calculate the both values together is the solution or complete solution of the linear differential equation with constant quotients. So, here what is the q of x value? Based on that we are having the different methods. So, if you are having q of x equal to e power x, we are following method 1. So, how to solve that equation? We can see in the method 1. So, if you are having here sin ax or cos ax. So, in place of q of x, if you are having sin ax also, cos ax also, we can follow the method 2. So, these two methods already we discussed in the previous videos. If you want, please go through that videos. So, third method we are going to discuss today. What is the third method is in place of q of x. If you are having x power k or x power m or x power n, so whatever the notation may be, so x power values. For that, we are going to follow the method 3 procedure. So, what is the procedure for the method 3? We are going to see here. First of all, when you are having f of x equal to x power n or q of x equal to x power k or x power m. So, where m is the positive integer or where k is the positive integer, then what is the formula for the particular integral? Particular integral equal to 1 by f of d into q of x, otherwise 1 by f of d into f of x. So, in place of f of x or q of x, we are having x power n. So, 1 by f of d into x power n. If we are having this form, what is the procedure we are going to follow? So, see here in the first step, take the lowest degree term common. We have to take the lowest degree term common from the f of d value. So, what is f of d? Already we wrote here. So, here what is the equation they are going to give in the problem? We are writing here for the f of d part. So, from that we have to take the common lowest degree term common. So, after that what we have to get the expression in the form 1 plus or minus pi of d. So, after taking the lowest term common, we can get the value like this, that is 1 plus or minus pi of d. So, after that we have to convert this one as 1 plus or minus pi of the whole inverse. So actually this will be in the denominator. So when you are taking this one into the numerator, then we can write this one as a 1 plus or minus pi of the whole inverse. 1 plus or minus pi of the whole inverse. So after converting this, we have to expand this value. Expand the 1 plus or minus pi of the whole inverse using the binomial theorem. So by using the binomial theorem up to the nth degree. Up to the nth degree, what is the value we are getting in the question? Based on that, we have to expand. So here, operate on the numerator term by the term by taking d equal to d by dx. So this is the important form. So this is the operator. Capital D is nothing but the derivative and 1 by d is the integration. These two terms are the basic terms we have to remember. So here what is the change for the x power n? We have to take the common lowest term to get the expression 1 plus or minus pi of d. So after that we have to take this one into the numerator, then we can find the value 1 plus or minus pi of the whole inverse. After that we have to expand this value by using the binomial theorem. According to the given equation, how much value we need, up to that we can expand in the n degree. So we will get the better clarity after seeing the examples here. So first of all, how to expand 1 plus or minus pi of d whole inverse by using the binomial theorem. Here we are giving some notations. We can observe these formulas. So 1 plus x whole inverse is equal to, here we are having plus, here we are having minus. So that means we are going to get alternatively plus and minus. So 1 minus x plus x square minus x cube plus and so on, like this. So how much value we need, up to that we can expand. And here also minus and power also minus. So then we will get all values are plus. So 1 plus x square plus x cube plus and so on. And here 1 plus x whole power minus 2. Here plus is there, here minus 2 is there. So 1 minus 2x plus 3x square minus 4x cube. And here for the here also minus, here power minus 2. Then we can write all plus values, 1 plus 2x plus 3x square plus 4x cube plus and so on. Like this we are going to use these formulas or these expansions in the problem. So we will see one example. See the question. Solve the differential equation. What is the differential equation? They given d square y by dx square minus y equal to 5x minus 2. So here we can write this one in the operator form. First of all, d equal to d by dx, and here we are having d square equal to d square by dx square. That means in place of d square by dx square, I can replace the capital D. So d square y minus y equal to 5x minus 2. Now I can write the operator form, d square minus 1 into y equal to 5x minus 2. This is in the form f of d into y equal to q of x. So first of all, what is the solution of the given non-homogeneous differential equation? Y equal to CF plus PI. So we are going to get CF from the f of d, and we are going to get particular integral PI from the q of x. So first I am calculating CF. So complementary function. So what is the f of d? F of d equal to d square minus 1. So here one important point you have to remember, for all problems, for the homogeneous also or non-homogeneous also, there is no change in the complementary function. So as it is, we can follow to calculate the complementary function for the homogeneous and non-homogeneous equations also. So here f of d equal to d square minus 1. Now I am writing the auxiliary equation. What is the auxiliary equation? Auxiliary equation is f of m equal to 0. That means I can write this one as m square minus 1 equal to 0. So m square equal to 1. So m equal to plus or minus 1. This is only we wrote here. So m equal to plus or minus 1 means here m1 equal to 1 and m2 equal to minus 1. Here two roots are distinct and real. So what is the complementary function? I can write c1 e power m1x. What is m1 value? 1. plus c2 e power minus m2x. So here m2x means minus 1. So we are getting here minus. So finally complementary function is c1 e power x plus c2 e power minus x. That means first part is completed. So complementary function is completed. Now we are going to find the particular integral according to the q of x value. See here, what is the formula for the pi? So particular integral equal to 1 by f of d into q of x. What is the q of x value we are having here? 1 by f of d into q of x value is 5x minus 2. 5x minus 2. So what is the f of d? F of d is d square minus 1 into 5x minus 2. So here we are going to follow the procedure for the x power k form or x power n form. So what steps we have to do here for the x power k? So first step we have to take the common lowest degree term common. So then we can get the form 1 plus or minus pi of d form. So after that, second step we have to write this one as by using the numerator form, that is 1 plus or minus pi of d whole inverse. After that we have to expand this form by using binomial theorem. So we have to expand this form here by using binomial theorem. So after that we can apply to solve the equation. So here 1 by d square. Here d square minus 1 means here I have to take the lowest degree term common. So lowest degree here d power 0. So 1 I have 1 already is there. So that means I have to take here minus common to get the form 1 plus or minus pi of d. So 1 by minus of 1 minus d square. Here so 1 plus or minus d form we got. So we can take this one into the numerator now. So minus 1 minus d square whole inverse into 5x minus 2. Now I am having 1 minus x whole inverse. So what is the expansion for the 1 minus x whole inverse? 1 plus x. In place of x I am having d square plus 1 plus x square. So d square whole square and so on. Here I am having the value 5x minus 2. So here one differentiation is enough. For the second differentiation we are going to get 0. So based on that we have to write the terms minus of 1 plus d square plus and so on of 5x minus 2. Now I am going to apply this operator on 5x minus 2. So minus 1. So minus 5x minus 2 plus into minus. Now d square of 5x minus 2. So here minus of 5x minus 2 minus first derivative is 5x minus 2, 5. X value is 1. If you are applying second term, we are going to get here 0. So 2 times differentiation. So d of 5x minus 2 is 5. So d square of 5x minus 2 is 0 because this is the constant. So this value is 0. So finally pi value is minus of 5x minus 2 is nothing but minus 5x plus 2. So this is the particular integral value. So already we calculated complementary function. So finally we can write the general solution or complete solution. So complete solution is y equal to CF plus PA. What is the CF value? C1 e power x plus C2 e power minus x. Here PA value is minus 5 plus 2. This is our complete solution or general solution of the given equation. So this is the way to solve the given equation by using the method 3. That means if you are having q of x equal to x power k. See the one more example here. Solve the differential equation. So the differential equation is d power 4 plus 4d square into y is equal to x square plus 1. So as it is like procedure we are going to follow here. Now, so what is the operator form? F of d into y equal to p of x. What is the procedure we are going to follow here? So first, what is the solution? Solution is y equal to yc plus yp. Nothing but complementary function plus particular integral. So first I am calculating complementary function. So what is the complementary function? So first of all, we are going to write f of d value. F of d value is d power 4 plus 4d square. So now auxiliary equation is f of m is equal to 0. So what is the f of m value? M power 4 plus 4m square is equal to 0. Now m square take the common. So m square plus 4 is equal to 0. So m square equal to 0 and m square plus 4 equal to 0. That means here we are getting m equal to 2 zeros. That means m1, m2, and here m square equal to minus 4. So m equal to plus or minus 2i. So here I am having 4 roots and here 2 roots are equal, here 2 roots are equal and complex. So now what is the complementary function? If 2 roots are equal and real, what is the complementary function? C1 plus C2 into x into e power mx. So that value is e power 0 into x plus here alpha value is 0. We are having the complex roots here. So C3 0x in C3 cos 2x plus C4 sin 2x. So finally this is yc equal to C1 plus C2x in e power x is e power 0 is 1 plus here e power 0 is 1 C3 cos 2x plus C4 sin 2x. So this is only our complementary function. Same value we got here. So that means first step is completed. First step is completed. Now we are going to find the particular. Now particular integral equal to 1 by f of d into p of x. What is f of d value? 1 by d power 4 plus 4d square. And here p of x value is x square plus 1. Now we have to take the common lowest degree term. What is the lowest degree here? D square. So first I am taking here 4d square common. 1 by 4d square common. Then 1 plus d power 4 by 4d square into x square plus 1. So here d square will be cancelled. Finally I am getting 1 by 4 is the constant. And for 4d square is the constant. And I am taking this one to the numerator. So d square by 4 whole inverse into x square plus 1. Now I can expand this one by using the binomial expression. So 1 by 4d square into, so here plus, here minus. That means we are going to get alternative plus and minus. And here x power is 2. So that means d square is enough. So for the d cube we are going to get 0. So 1 plus x. So here 1 plus and minus we are having means alternative plus and minus. So 1 plus minus d square by 4 and again plus d square by 4 whole square plus and so on into x square plus 1. So now 1 by 4d square as it is. Now we are going to multiply with x square minus 1. So 1 into x square plus 1 minus 1 by 4 d square of x square plus 1. This term is enough because we are getting here constant. So 1 by 4d square. First term is x square plus 1 minus 1 by 4 into, so d square of x square. So d of x square is 2x and d square of x square is 2. So this value is 2. So we can observe here the value 1 by 4d square into x square plus 1 minus 1 by 2. So finally what is this value? 1 by 4d square into x square plus 1 by 2. Now we can apply the 1 by d square on the two terms. So first we will calculate 1 by d. So 1 by d into 1 by d means integral x square dx plus integral 1 by 2 into dx. So now one operator, so 1 by 4 into 1 by d. So integral x square value is x cube by 3 plus 1 by 2 into integral dx is x. Now again I am going to apply 1 by d on this. So 1 by 4. So again integral x cube by 3 dx plus 1 by 2 is the constant integral x dx. Now what is the final value 1 by? This is 1 by 12. Integral x cube is x power 4 by 4 plus here 1 by 4 2s are 8 here. Integral x is x square by 2. So finally what is this value? X power 4 by 12 4s are 48 plus here x square by 8 2s are 16. So this is our final value. So that means this is the particular integral. So already we calculated complementary function. This is the particular integral. Together is the complete solution. Nothing but general solution. So what is the general solution here? Y equal to CF plus PI. So here complementary function is C1 plus C2x plus C3 cos 2x plus C4 sin 2x plus 1 by 4. Otherwise x power 4 by 48 plus x power 4 by 16. So this is our general solution of given equation. We will see one more example here to get a better clarity of this procedure for the x power k. So see the next example. Solve the differential equation. What is the differential equation? D square minus 6t plus 9 into y is equal to 1 plus x square. So here what is the f of d? F of d equal to d square minus 6t plus 9 and q of x equal to 1 plus x square. So first of all we are going to calculate the complementary function by using the f of d. So what is auxiliary equation? Auxiliary equation is f of m equal to 0. So same square minus 6m plus 9 is equal to 0. So from this I can calculate the roots. So I am getting here m is 3, 3. So finally what is the complementary function? Complementary function equal to C1. Here two roots are equal and real. So what is the formula for that? C1 plus C2 into x into e power 3x. This is our complementary function. So next we are going to find the particular integral. So what is the particular integral formula? 1 by f of d into q of x. So here we are going to replace f of d value. What is the f of d value? D square minus 6t plus 9 into what is the q of x value? 1 plus x square. So here we have to take the common lowest degree terms. So here first I am taking the common 9 value. So 1 by, take the 9 common. So 1 plus this total value we treated as d. So d square minus 6t by 9 into 1 plus x square. So now I'll take this one into the numerator. So 1 by 9 into 1 plus d square minus 6t by 9 whole inverse into 1 plus x square. This is only. So now we can expand this one by using the binomial expression. So here 1 by 9. This is equal to 1 by 9. 1 plus d square minus 6t by 9 whole inverse into 1 plus x square. We can take it as it is also. Otherwise we can expand like this as a separate terms. So 1 by 9, 1 plus, this is the plus and minus, alternatively plus and minus we are going to get here. So 1 minus d square minus 6t by 9. After then plus square d square minus 6t by 9 whole square plus and so on. Here I am having the value up to square only. So first two terms are enough. So 1 by 9. First 1 minus, here I am going to simplify this one, minus d square by 9 plus 6d by 9. And here remaining we are going to get here d square minus, this is 1 by 9 9s are 81. So here d square minus 6t expansion. If you are having d square minus t whole square, So a square is d power 4 plus 36d square minus 2ab. That means d cube we are getting. So we no need d cube and d power 4. Only will 6. Take the 36. So 36d square. So into 1 plus x square. So now what is the final value? 1 by 9 into 1 plus x square is as it is. So 1 plus x square minus 1 by 9 into d square of 1 plus x square. So what we have to do here? D square of 1 plus x square. So first derivative is 1 is 0 plus x is 1 and second derivative, first derivative is 2x here. If you are applying d square again, so 1 is 0 plus 2 into x is 1. So this value is 2. This value is 2 plus 6 by 9 d of 1 plus x square. So 1 is 0, x is 1 plus x square is 2x. In the same way, 36 by 81, d square of that value is 2. So this is the final term. Now we are going to simplify this. We are getting the term here. So 1 by 9, 1 plus x square, and here 2 by 9 here. So here after simplifying these two constants, we are getting here plus 2 by 3 and one more 2 by 3 also is there. And here x term is we are getting here 4x by 3. So this is the final value. When you are taking the after simplification, the final value pi equal to 1 by 9, 7 by 3 plus 7x by 3 plus x square. So this is our particular integral. Here directly you can take d square minus 60 by 9 as a d. Otherwise we can separate the terms and we can apply on 1 plus x square. So what is the procedure? If you are feeling easy, you can take that. So but when you are applying the operator, you have to take care. So finally our particular integral is 1 by 9, 7 by 3 plus 7x by 3 plus x square. So our pi also completed. Now what is the complete solution or general solution? Y equal to CF plus pi. So finally what is the CF value? E power 3x into C1 plus C2x plus 1 by 9 into 7 by 3 plus 7x by 3 plus x square. This is our final solution of a given equation. So this is the procedure to solve the given equation if the given q of x equal to x power k. I hope you understand this procedure for the q of x equal to x power k. If you want more examples, please refer these textbooks. Higher Engineering Mathematics written by B.S. Gravel and a textbook of Engineering Mathematics written by N.P. Bale and Manish Goyal, and one more textbook also is there for the basics, Higher Engineering Mathematics written by B.B. Ramana. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.